is an interesting geometric problem that will truly challenge your thinking, and the solution will leave you in a maze. We have a quarter circle. Inside, we have a semicircle and a circle like this. The circle and the semicircle are touching each other externally at this point. And this circle is touching the quarter circle internally at this point. The radius of this circle is m units. And we are required to find the value of the radius of this circle. Can you solve it? Before we start, we must understand two things. Imagine we have two circles that touch each other from the outside. If we draw a line joining the centers of both circles, this line will also pass through their common touching point. Why is it so? Because if we draw a tangent at that touching point, then this line will be perpendicular to this tangent, and the line is also the radius of this circle. Similarly, this line will also be perpendicular to this tangent line, and this is also the radius of this circle. So one radius makes 90 and the other radius 90. Together we have 90 plus 90, which is equal to 180 degrees. This shows that the two centers and the touching point all lie on the same straight line, which makes them collinear. In the same manner, we can show that if we have two circles which are touching each other in the inside with here as the common point, if they draw a line that connects the center of the two circles, then it will also pass through this common point. With this idea, solving the problem becomes easier. Consider this semicircle and this circle. Connect their centers so it will pass through this point of contact, right? This piece is the same as the radius of this semicircle, which is m. And this piece is for the radius of this circle, which is r. So the whole length will be m plus r. Now let us draw a horizontal line like this. This line labeled m is the same as the radius of this semicircle. This line labeled r is the radius of this circle. So this line will be equal to m minus r. Let us label this side as x. So our next step will be to use Pythagoras theorem to solve. So it will be x squared plus the bracket of m minus r squared equals to the bracket of m plus r squared. X squared will be equals to bracket of m plus r squared minus the bracket of m minus r squared. Now we are going to apply this concept to expand it. Now when we expand it, we have bracket of m plus m minus r times the bracket of m plus r minus m minus r. So x squared will be equals to 2m times 2r. Finally, x squared equals to 4mr. Consider this quarter circle and this circle connect their center, so it will pass through this point. The radius of this quarter circle equals to 2m. This piece is r, so this will be 2m minus r. Now the length of this is just the same as that length called x. We can use Pythagoras theorem on this right angle triangle. So x squared plus r squared equals to bracket of 2m minus r squared. So x squared equals to 4mr. So 4mr plus r squared equals to 4m squared plus r squared minus 4mr. R squared cancels r squared. We are left with this. And when we solve further, we are going to have r equals to m over 2. Thank you for watching. If you have gained value in this lesson, kindly subscribe to my YouTube channel. Bye.